Assalamu alaikum. This is the first lecture in a series of presentations on vocal fold palsy, starting with the effect of laryngeal denervation on individual laryngeal muscles' function and dysfunction. The variability in the vocal fold's position and functions after denervation and its clinical presentation has been noted and debated since the 19th century. The core reason for this is that laryngeal paralysis, vocal fold pulses, are not always an all or none phenomena. It's rather a spectrum of residual nerve functions and attempts at re-innervation and attempts at compensation. So there is a spectrum of nerve injury. It's not always total injury of the nose, total nerve damage. Sometimes or often it is actually partial, and there is always some attempts at compensation and frequently some attempts at re-innervation. And this would account for the variability in the clinical presentation, the position of the fold, the vocal fold, the range of movements and residual function. The variability in the vocal fold, the paralyzed vocal fold position and functions in vocal fold palsy is the total sum of the individual muscles' dysfunction variability. This in turn depends on these factors and maybe more. The degree of the denervation, whether it is complete or incomplete, partial or not, the extent of re-innervation, the contracture or atrophy of the denervated vocal fold muscles, the individual variations in the anatomy of the laryngeal muscles, the variations in the mass of the muscles, its length and its stiffness, and any compensatory laryngeal movements. During voice production, the vocal folds oscillates rapidly. This oscillation modulates the glottal airflow into a train of air puffs with a certain frequency. You can see the fundamental frequency of the glottal signal in here. This fundamental frequency keeps on changing quite rapidly and sometimes significantly under the control of the same set of laryngeal muscles that can induce all these changes in the fundamental frequency. They do that through two things: the redistribution of the stiffness along the vocal folds and also the changes in the geometry of the vocal fold, the length, the breadth, and the depth. The laryngeal muscles, through their direct effect on several factors, can determine the fundamental frequency required. These factors are not completely independent. They can interplay and affect each other, including the vocal fold stiffness, the intrinsic property of the vocal fold, a physical property of the vocal fold itself, and the tension applied to the vocal fold in terms of either stretching or compressing the vocal fold along its anteroposterior direction, changes in the vibrating mass of the vocal fold, the part of the vocal fold that vibrates during the oscillation can be changed by changing the vocal fold length, the depth of the vibrating ends of the vocal fold, the glottal channel geometry. So vocal fold length is important, the extent and the depth, and also the duration of the vocal fold contact is important, and also factors like the subglottal pressure would also influence the fundamental frequency. We will now go through the effect of individual laryngeal muscles on the glottal fundamental frequency. The lateral crico-arytenoideus is the major adductor of the vocal fold, helped in part by the inter-arytenoideus muscle. The lateral crico-arytenoideus induces mainly an inward rotation of the arytenoid across the posterior plate of the cricoid cartilage. This inward rotation would help in closing up the posterior cartilaginous glottis. It also would help in the adduction of the posterior part of the vocal folds towards the midline. The inter-arytenoideus muscle connects the posterior parts of the arytenoids and also help in the sliding of the arytenoids towards the midline to meet together in the midline, closing up the posterior part of the glottis. The combined effect of these two muscles is to completely close the posterior glottis, but the mid part of the membranous glottis would still have a small gap, and there will also be a reduced contact and reduced thickness of the medial ends of the vocal folds in this area. This may lead to a breathy voice. This persistent gap would need the activation of other muscles, mainly the vocalis part of the Thyro-Arytenoideus muscle. The direct effect of the lateral crico-arytenoideus is to adduct the vocal folds by bringing them both towards the midline, helped by the inter-arytenoideus. But they don't have much effect on the vocal fold length, and also a slight effect on the vocal fold stiffness. They only cause slight medial compression of the membranous part of the glottis and no change in the vertical thickness of the medial part of the vocal fold, the contact area of the vocal folds. This may cause incomplete glottal closure in the mid-membranous part. The indirect effect of these two muscles is to stabilize the arytenoid during its movement, to adduct the vocal folds. They stabilize its position over the cricoid cartilage, helped also by the posterior crico-arytenoid, which is an abductor, but it activates during the adduction to help in the stabilization of the arytenoid cartilage. And now the Thyro-Arytenoideus muscle, which forms the bulk of the vocal fold. When activated, the Thyro-Arytenoideus muscle will induce a whole body rotation in the axial plane and the horizontal plane around the axis of attachment to the thyroid and the arytenoid. The whole of the muscle would rotate medially, and this will close up completely the membranous part of the glottis. It would leave the posterior part of the glottis open. To close up the glottis completely, you would need the activation not only of the Thyro-Arytenoideus, but also the lateral crico-arytenoid and the inter-arytenoid, which would close up the remaining posterior part of the glottis. The effect of the Thyro-Arytenoideus muscle, the vocalis muscle, on the vocal fold fundamental frequency is a little bit more complex. The Thyro-Arytenoideus muscle tends to stiffen and tense the vocalis muscle itself, the body layer of the vocal fold tissues, the core layer. But at the same time, it shortens the vocal fold length, and this would lead to a decrease in the stiffness of the cover layer of the vocal fold. So there will be an increase in the stiffness of the core layer of the vocal fold and a decrease in the stiffness of the cover layer. This change in the body cover stiffness ratio was noted to increase the duration of the glottal closure and also increase the vocal fold frequency. On the other hand, depending on the depth of the body layer involved in the vibration, the increase in the Thyro-Arytenoideus activation can either increase or decrease the vocal fold fundamental frequency, as we should see now. The final effect of activation of the Thyro-Arytenoideus muscle on the vocal fold fundamental frequency can vary depending on several specific vocal cord conditions. We'll go through three of these conditions. And the first two specific conditions, they relate to the condition of the vocal fold length. If the vocal fold is elongated, as is often the case during phonation, then activation of the Thyro-Arytenoideus muscle would lead to a decrease in the vocal fold fundamental frequency, a drop in the F0. But if the vocal folds are only slightly increased or slightly compressed, then activation of the Thyro-Arytenoideus muscle would actually increase the fundamental frequency. The other factor is the effect of the activation of the Thyro-Arytenoideus on the vertical depth of the medial edge of the vocal folds during phonation. It would tend to increase the vertical depth of the vocal fold, and also it will produce more medial compression between the vocal folds during their contact. So both these factors, the increase in the vertical depth and the medial compression of the two vocal folds medial ends, would tend to increase the extent and the duration of the vocal fold contact during the vibratory cycle, and both these factors would lead to an increase in the fundamental frequency. So the final effect of Thyro-Arytenoideus on the vocal fold fundamental frequency would vary. Sometimes it would increase, sometimes it would decrease the fundamental frequency depending on the vocal fold specific conditions. So with any weakness or delay in the action of these three muscles, the lateral crico-arytenoid, the inter-arytenoid, or the thyroarytenoids, there will be a longer open phase of the glottis during the vibratory cycle. The glottis would remain open a bit longer than it should in the vibratory cycle. Normally, the open phase should be 0.40% to 70% of the vibratory cycle. If it is more than 70%, the ratio between the open phase and the total time of the vibratory cycle is more than 0.7. Then this would lead to a short contact period between the vocal folds and would allow a rapid airflow through the weakened adduction, and this would cause a turbulence. In more severe cases, when there is sufficient separation of the two vocal folds away from each other during phonation, the coupling between the two vocal folds to produce a single fundamental frequency may be weakened, and each vocal fold may vibrate at a different fundamental frequency, leading to biphonation, or a voice containing two distinct fundamental frequencies. Moving now to the cricothyroideus muscle. The cricothyroideus is formed of two bundles. The vertical bundle is the pars recta, approximates the cricoid and the thyroid cartilage by rotation of the cricothyroid joint. The oblique bundle, the pars oblique, with fibers running upwards and backwards, on activation displaces the cricoid cartilage, and on top of it the arytenoid backwards in relation to the thyroid cartilage. This would lead to a stretching of the vocal folds, increasing the length of the vocal fold, and also increasing the stiffness and the tension in both the vocal fold body and also the cover layer of the vocal folds. The effect of the cricothyroideus on the vocal fold fundamental frequency depends on a special property, physical property of the vocal fold, in that it has a nonlinear stiffness, nonlinear material stiffness of the vocal fold. If the vocal fold stiffness is linear, then a stretching of the vocal fold in one direction would increase the length, but it would not change or increase the stiffness of the vocal fold. But because the material of the vocal fold has a nonlinear property, the stretching of the vocal fold in the anteroposterior diameter would increase both the length of the vocal fold and also the stiffness both in the body and the cover layer of the vocal fold. This is of special importance in the control of the fundamental frequency. So to sum up the factors that influence the vocal fold's contact pattern, the way the medial ends of the vocal folds meet up in the midline during oscillation will depend on things like the degree of vocal fold approximation under the influence of the adductors. This is how the lateral crico-arytenoideus, the inter-arytenoideus, and also the Thyro-Arytenoideus can affect the contact pattern. The other factor is the glottal channel geometry, the extent and the depth, and also the duration. The extent and the depth are influenced by, for example, the Cricothyroideus muscle that reduces the vertical depth of the glottal channel, and this would lead to an increased fundamental frequency. On the other hand, the Thyroarytenoideus would increase the vertical depth of the glottal channel. Another factor is the subglottal pressure. The higher the subglottal pressure, the easier it is to open up a closed glottis during phonation. And the vocal fold stiffness. All these factors would interplay to affect and control the vocal folds contact pattern during oscillation. When the medial ends of the adducted vocal folds are thin, they can be easily pushed apart by the subglottal pressure. As a result, the glottis may never completely closes during vibration, producing a weak and breathy voice. On the other hand, increasing the vertical thickness of the medial ends of the vocal folds during phonation provides a better closure that can resist the glottis opening effect of the subglottal pressure. Also, increasing the thickness would increase the phase difference in the pace between the inferior part and the superior parts of the medial ends of the vocal folds, and this would produce a longer closed phase of the vibratory cycle. And finally, these two muscles, the cricothyroid and the thyroarytenoideus, can also change the glottal geometry, the configuration of the glottal canal during phonation, the mode of contact of the two vocal folds. The cricothyroid muscle would stretch the vocal folds and reduces the vertical thickness of the vocal folds medial edges, whereas the activation of the thyroarytenoideus muscle would do the opposite. It would increase the vertical thickness of the vocal fold medial edge and also help in the medial bulge of the inferior part of the vocal fold medial edge during phonation. The action of the thyroarytenoideus here would help with a better and a longer contact mode of the two vocal folds, whereas thinning and stretching of the vocal fold edges by the cricothyroid would do the opposite. By this, we come to the end of this first presentation on vocal fold palsy, the effect of laryngeal denervation on individual laryngeal muscles. Assalamu alaikum.